This is a subject design thinking presenting by Mr. R. Srinivas, DBS Institute of Technology, KAVALI, Nellore district. We are going to continue this second video from this unit. We are going to continue different types of energies we are trying to learn. Slides, okay? Kinetic energy we are going to see about. It is the property of a moving object or particle, and it depends not only on its motion, also mass, thermal energy. It refers to the energy contained within a system, that is temperature. Means temperature is the plays major role on thermal energy magnitude. Electrical energy, it is a form of energy resulting from the flow of electric charge. Chemical energy, the energy stored in the bonds of chemical compounds. Chemical energy may be released during a chemical reaction. Nuclear energy is energy in the nucleus of an atom. Atoms are tiny particles that makes up every object in the universe. Conversion of rotary motion to linear motion. Conversion, okay, rotary motion to linear motion. Excellent. A slider crank mechanism is nothing but a 4-bar mechanism. It's actually a slider crank mechanism is a typical design. Once you see the figure, once it is rotating, this lever, it is a slider can slides, okay, translator in motion. A slider crank mechanism is a typical design which converts rotary motion into linear motion. It is achieved by connecting a slider and a crank with a rod, okay, crank and slider. Figure depicts, okay, figure explains us a mechanism utilized as a system that converts the reciprocating to linear motion of the automobile engine. Applications: bolt and nut, okay, lead screw, bench vise, okay, cutting machine, slotting machine. Here, conversion of motion, okay. Advantages: direct conversion of rotary motion to linear motion. Okay. Easy construction and operation, can perform cutting and slotting easily. Disadvantage: high bearing rate due to direct contact. Okay. Less application in real life. Conversion of linear motion to rotary motion. A rack and pinion mechanism is a simple design which converts linear motion into rotary motion. It is achieved by connecting a rack and pinion on each other. Figure depicts, it explains a mechanism utilized as a system that converts the linear to reciprocating motion of an automobile engine. Okay, it's available, you see now. Applications, car steering function, lathe carriage, okay, printer, etc. Advantages, easiest way to convert linear motion into rotary motion. Easy construction and operation, cheap, robust, rack and pinion gives easier and more compact control over the vehicle. Disadvantage, high wearing rate due to direct contact, less durability. Okay, vibrations, motion transmission mechanism. Okay, motion transmission mechanism. The motion transmission systems allows a transfer of mechanical energy from one object to the another object, changing the nature of the movement. Example, in a gears or friction wheels, the motor wheel transmits its rotational moment to the following wheels. Newton laws, very, very important. Engineering mechanics depends upon the Newton's laws only. First law, it states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. It is also called law of inertia. It is also called law of inertia. Second law, the force on object is equal to its mass times its acceleration. It is also called rate of change of momentum with respect to time is nothing but is equal. It depends upon applied load. Third law, for every action, there is an equal and opposite reaction. Applications of Newton's first law. A book lying on a table remains at its rest as long as no net force acts on it. A moving object does not stop moving by itself. Applications of Newton's second law. Kicking a ball. When we kick a ball, we exert force on a specific direction, which is the direction in which it will travel. That means it will travel on the direction of the force application on it. In addition, the stronger the ball is kicked, the stronger the force we put on it and the further away it will travel. Pushing a cart. All the figures are available on the slide. It is easier to push an empty cart in a supermarket that it is to push a load one. More mass requires more force to accelerate. Applications of the Newton's third law. While firing a bullet, the gun must be held tight to the shoulder. When a man jumps from a boat to the shore, the boat slightly moves away from the shore. Rocket works on the principle of conservation momentum. Pascal's law is a very, very, very important law. The pressure application applied to any part of the enclosed liquid will be transmitted equally in the direction to the liquid. It is also called principle of transmission of fluid pressure. Formula P is equal to F by A. P pressure, F is force, A is cross-sectional area. Application of Pascal's law, hydraulic lift. It's a very, 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 very vital example, excellent example. Application is hydraulic lift. Okay, through works with mm, um, Pascal's law, according to the words. Hydraulic jacks also. Hydraulic brakes also. Hydraulic pumps works according to buoyancy. Buoyancy is an upward force exerted by a fluid that opposes the weight of a partially or fully immersed object. In general terms, this buoyancy force can be calculated with the equation Fb is equal to Vs into d into g, where Fb is buoyancy force that is acting on the object, Vs is the submerged volume of the object, d is the density of the fluid the object is submerged in, and g is the force of gravity. Applications of the buoyancy: cargo ships, boating, hot air balloons. Excellent, excellent. Bernoulli's theorem. We are covering engine mechanics, structurometers, and fluid mechanics, and all we are covering in our subject, that is design thinking. It states that as the speed of a moving fluid increases either liquid or gas, then pressure within the fluid decreases. P by rho g plus v square by 2g plus h is equal to constant. Okay. Applications of the Bernoulli's theorem: moving cars, aeroplanes. Okay. Ohm's law, it is electrical engineering. Okay. Ohm's law states that current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Okay. Voltage current is the resistance. V is equal to IR. Okay. V voltage, I is current, R is resistance. SI units of the resistance is ohms and is denoted by applications of Ohm's law: electric heaters, electric kettle and iron boxes, design of electric devices, fuse design, mobile or laptop charger, electromagnetic induction. It is the production of an electric current by charge changing the magnetic field enclosed by an electric circuit. Okay. Or the phenomenon of generation of the current or EMF by changing the magnetic flux is known as electromagnetic induction. EMI example: electric generator. Applications of the electromagnetic induction. Applications of the electromagnetic induction: washing machines, trains, electronic hubs, cookers, transformers, welding, ends. Okay, all of you. Thank you for all for listening all the slides carefully. Thank you very much. Sir?